This video is going to look at answering word problems at level 2 NCEA, mostly merit and excellence. I'm going to assume, for the purposes of this, that you can do all the actual algebra skills, the solving and the rearranging, because we're only going to focus on the process itself. And this is the steps I suggest, but they don't mean much until we've seen them in practice, so let's run through them. We have a question from a few years back, quite difficult in fact, but that doesn't matter because we're only going to worry about the process. So, number one step, we scan through our question and we find the number that we're going to need at the end of our equation. What is it we are trying to make something equal to? And we're trying to make it something equal to 3. So, we know 3 equals something. Next step, what does 3 equal? We write that in general terms. 3 is the difference between two positive numbers, so in general terms, that's the difference between two positive numbers. Next step, we rewrite that in terms of one variable, because you can't solve 3 equals a minus b, because there's two variables in only one equation. So we go and we look, and we see how we can relate a to b, and we can relate a to b because we're told the difference between their reciprocals is 1 over 90. Reciprocal is 1 over a number, so we write that down. The difference between 1 over b minus 1 over a is 1 over 90. Now, it's actually quite tricky to solve, but we'll go through it quite quickly. We rearrange that second equation, we make the denominators the same, we add them, then we flip the two fractions upside down, and now we have b in terms of a. So if I've got b in terms of a, I can replace b in my general equation with b, and so I can write it in terms of a, which I will do. So now we've rewritten our general equation in terms of only a variable we want to solve. Next step, step 4, is to solve it, and the steps very quickly. Rearrange it to the other side, multiply the denominator up, expand, stick it in our calculator in the form of a quadratic, and we are told a is 18 or minus 15. It's solved. But solving is not the end of the story, because we need to answer in the context provided. In this case, we are told there's two different positive numbers. There's 3. Well, minus 15 isn't positive. That one has to go. We're also told what are the two numbers. So we have to answer two numbers. They differ by 3. And so we write our answer. The numbers are 15 and 18. It would pay to check it on a calculator that's right before you move on. Is 1 over 18 minus 1 over 15 equal to 1 over 90? And it is. So let's do that one more time. We have a rectangular garden, 12 by 15. There's a path around it. If the area of the path is 60 meters squared, how wide is it? Now, at this point, first up, we draw a little sketch, because it makes it a lot easier if we can see what we're doing. Don't try to do these things in your head. Put it on sketch form so you can see what you're doing. First, then, let's find the number we need. We need the area of the path to be 60, so 60 is equal to the area of the path. And the area of the path, in general terms, is the blue rectangle minus the white rectangle. So we're going to do that. 60 is the blue area minus the white area. Now we need to rewrite that in terms of one variable. First thing, we can get rid of the white area because we know that's 12 times 15 is 180. Next, we have to write the blue rectangle size in terms of what we want, and what we want is the width. So the width of the path all the way around we're going to call W, and so the length from one side to the other is now 2W more than it was before. 15 plus 2W, 12 plus 2W, so we write that blue area in that form. Now we have the answer we need, 60, in terms of only one variable, and the next step is to solve. Expand it out, make it equal to 0, stick it in our calculator. So W is 1.03 or minus 14.53. We have to answer in context. Well, a negative width of a path makes no sense. It works mathematically, but it makes no sense. So we have to ignore that one, and we write that our path is 1.03 meters wide. Okay, so let's run through that process. Search through the question, find what you need your equation to equal. Write that in general terms, not worried about the specifics, just in general terms, and often a sketch can be really helpful to set up what you're expected to do. Then, and this is the key bit, this is the bit that determines whether you can do these questions or not, you rewrite that equation in terms of only the variable you want. You may find some of the information you need is geometric. You may have to do a substitution of a simultaneous equation, but whatever it is, you end up needing to have only one variable. You solve that equation, usually a simple quadratic, and then you answer the question in context.